We're going to use implicit differentiation to find the derivative of this equation right here. Notice it's got a y squared in it. It's got another y in it. It would be complicated, possible in this case, but complicated to find the y equals version. So it's much faster and more useful to find the derivative using implicit differentiation. First thing I'm going to do is rewrite this so it's a little bit easier to see. So I've got x squared minus 3x, I'm going to put a dot there for times y, plus 4 bracket y close squared equals 8. Now I'm going to ddx this. That means take the derivative with respect to x. I'm going to underline some things here. I'm going to underline the first term and the second term. And actually, I didn't quite do that right because I want to include the whole minus on that second term or that first term. So the derivative of the first term, the first term is minus 3x. If you think about it that way, then you'll make less errors, and the AP likes to include those minuses in these types of problems. So when I ddx this, I get 2x for the first term. Easy peasy. Next one, the derivative of minus 3x is minus 3. That is the derivative of the first times the second, so I need to do y right here. That's because I'm using product rule. And then I get plus, now I get the derivative of the second. Well, what's the derivative of y with respect to x? It's dy dx. Next term is the first, right? So a lot of times people mess up this piece right here. The first is times minus 3y. A lot of times people will miss this negative on the second term of their product rule because they look at this and they say minus. Oh, it goes here. All right, then I get the derivative first is 3x, or is 3 times the y. And then they say, all right, y prime, dy dx, times, and we forget this piece right here. But, and they just write 3x. Oh, I wrote y. Hopefully you caught that. Now, plus, so this term here derives to this whole term there. So plus now I got to do the y piece, or the y squared piece, the 4y squared. So I get 4 times 2 to the first. What's this? The y slides in. And then what's my chain rule? Dy dx. And then I get that it's equal to, what's the derivative of 8? It is nothing. Y equals 8 is a flat line, so it has a slope of 0. So I'm going to rewrite this in a little bit easier to read way, and then we'll solve for dy dx. So I've got 2x minus 3y plus, look at me, minus 3x dy dx plus 8y dy dx is equal to 0. Now, I got to solve for dy dx. These two need to move over to the right side. So when I do that, I'm gonna subtract 2x and add 3y. That's going to give me an equal sign that has a plus 3y and a minus 2x. Now I will rewrite the remaining parts up here. I got minus 3x dy dx plus 8y dy dx. Now, this step, if you think about it the right way, it's an easy step to take. I'm going to write dy dx. Well, let me say I had 6x equals 12. You would divide by 6 on both sides to get it x equals 12. What if I had 3x plus 2x equals, that's a bad example. I'm just going to, if I had 3x plus 2x equals 12, I could write it as 3 plus 2 times x equals 12, which would be 5x equals 12, which gives me x equals 12 over 5. The key here is this factoring part right here. Let me just show you how to do it. I think it'll make sense to you. I'm going to write dy dx. I'm going to make a bracket, and then I'm going to rewrite this right-hand side right here. So 3y minus 2x. So to go from this step to this step, you need to figure out what I would need inside the bracket to make this line right here the same as that line right there. And I think you should see that I would need a negative 3x plus an 8y. Because if I were to distribute this dy dx in, I would get that line out. And now it's just like this, 6x equals 12, right? I'm going to divide by the 6. Oh my gosh. 2. I don't even know if I said 2. Anyway, I divided by the 6 on both sides to get the 2, right? So here, what I'm going to do is divide by the brackets on both sides. So I'm going to divide by 3x negative 3x plus 8y. Do it on the left side, do it on the right side. Negative 3x plus 8y. This cancels with that and leaves me with nothing but dy dx is equal to 3y minus 2x. And now I'm going to flip the order of these two because I just like having the positive term first. So 8y minus 3x. And that is the derivative of the slope of any point on this curve. Now, there's more that I can do with that, but for now we're just going to practice taking the derivative. So let's have you do one right now. Let's do x cubed plus 4, sorry, not plus, minus 4xy plus e to the y equals 5. I want you to find the slope of any point on this curve. So find dy dx for this curve. I would like you here to pause and try it, and then I'll pop the answer up for you. So pause it. All right, the answer is going to show up in a moment. Okay, so you should get this. 4y minus 3x squared all over e to the y minus 4x. Now, let me show you where that comes from. Oh, sorry, I should say, if you got that and you're good, you can fast forward this video to whatever timestamp I give you in your Google Doc, right? If you, actually, you know what? If you got that and you don't want to listen to me, you can just go. I'll end the video after this problem. If you didn't get that right or you just want to see me do it, then go ahead and watch the rest of this. So the first thing I do is I dx both sides. That gives me 3x squared for the first term. Now that is the first times that is the second. So when I do my product rule for this second term, I get minus 4y. That's the derivative of the first, minus 4 times the second, y. And then I'm going to get minus, well, I should say, I get plus dy dx, that is the second, times negative 4y. Then I get my plus. The e to the derives to e to the, so e to the y derives to e to the, but I need to multiply by the derivative of the innards with respect to x, so I need to multiply by dy dx. Equals, right-hand side, derives to 0. You may say, oh, the right-hand side is derived to 0. Well, one of the typical ways to write these implicit curves is to write all of this mess equals something. So that's why we've always got a number there on the right side. It's always going to derive to 0, unless there's x terms or y terms over there. All right, so from here, I'm going to do 2 steps at once. I'm going to take these two and move them over to the right side. That gives me 4y minus 3x squared. And at the same time, I'm going to write my dy dx, bracket it, and now I'm going to see what I need to have inside here to give me the remaining terms. So if you look at it, e to the y, that's this guy, right? And then this one is minus 4y. Why did I write it like that? Oh, no. Wait. Pause. Oh, all right. It's okay. I had a little error, and I'm not going to redo the whole video. This should be an x here. I'm sorry. So that changes this to an x. Hopefully you caught that. Why did I write them in that order? I wrote them in that order because I like to have the positive one first. And now I'm just going to divide by the bracket. If I do that, I get dy over dx equals 4y minus 3x squared all over e to the y minus 4x. And that matches this up here. So if you are good with this, great. And I think I'm going to do one more that's sort of like an AP style problem. And there'll be a new video for that. Bye.